All right, so now inverse trig functions. So we're going to reverse things a little bit, which we've kind of been doing, right? So we know our unit circle so well that when I say what angle has a cosine of root 3 over 2, you're like, a 30-degree angle has a cosine of root 3 over 2. If I'm like, what other angle, because we have to do all the angles on the circle, also has a cosine of root 3 over 2, you're like, oh, a 330. So there's two angles that have cosines of root 3 over 2. A little bit tougher is, can we name two angles that have tangents of root 3? Tangents of root 3. Doesn't a 60-degree angle have a tangent of root 3? Yeah. You got to kind of think about what other quadrant is tangent positive in. Tangent is positive in the third quadrant. The 60-degree angle, reference angle in the third quadrant is 240. So two answers. Cool. When is cosecant undefined? Well, cosecant is going to be undefined because cosecant, right, is 1 over sine. So cosecant's going to be undefined wherever sine is 0. Sine is y, so sine is going to be 0 at 0, 180, and 360. And we do the whole circle, including the 0 and the 360, right? So going all the way around the circle, which angles have those particular trig functions is something we've done already. But now we're going to do what we call a different version of these similar types of problems, only now the domain is restricted. The domain is restricted. So what that means is for different angles, or different trig functions, so for cosine, secant, and cotangent, we're only going to have whatever answer is between 0 and 180. So that means whatever answer is in the first or second quadrant. And then here, if a sine or cosecant or tangent, it's going to be restricted to between negative 90 and 90. That's actually the first and fourth quadrant. First and fourth. And then we have a little aside for their fourth quadrant angles. If it was like a 330-degree angle, we're going to say negative 30. If it's a 300-degree angle, we're going to say negative 60. Seems a little strange, but okay. Your calculator actually knows this too, which is interesting. So this is a different way to ask the same question, but now it's written as an inverse function. So we're asking what angle has a sine of negative 1? What angle has a sine of negative 1? And sine is restricted to first and fourth, so somewhere in here, this is going to be this angle right here as a sine of negative 1. Normally we would say 270, but we're going to actually say negative 90. And if you check that on your calculator and do second sine negative 1, you're going to be saying, wow, it does say that. It says negative 90, not 270. Huh, okay. So now we have tan inverse of root 3 over 3. So we know that this is our 30-degree angle, right? And tangent is restricted to the first and fourth quadrant. It's only asking for the angle that has a tan of positive root 3 over 3, so it's just 30. Onwards we go. Cotan is undefined, so this is saying what angle, cotan is restricted to first and second, what angle has an undefined cotan, which is the same thing as basically saying what angle has a sine of 0. And this is actually just going to be a 0-degree angle. You might be like, oh, wouldn't it be 182? And then here's where I realize I have a little mistake here. I shouldn't have that less than or equal to. It should just be less than. So that's guarantees you only have one angle. So that's my fault. It should just have been less than. So 0 less than or equal to 180, less than or equal to x less than 180. Then we changed notations. It says arc cos of 1/2. That's the same thing as saying what angle has a cos of 1/2. Cosine is restricted, inverse cosine to the first and second quadrants. The angle that has a cosine of 1/2 in that area is 60 degrees. Arc sine of negative 1/2. So sine is restricted to first and fourth. We know that's 30-degree family, right? So the 30-degree family angle that would have a sine of negative 1/2 is 330, but again, we would answer as negative 30. And you might be like, what if I wrote 330 on the test? it would be like a minus a half type of thing, right? We would know, we would want the answer as negative 30. But I would understand that you know what you were talking about if you said 330, but the correct answer is negative 30. Arcsecant of negative 2, you got to think about that. Well, the secant is negative 2 when cos is a half. Cos is restricted to first and second. Coses are 1/2 in the 60-degree family. So the angle that has a cos of negative 1/2 is going to be 120 degrees. So it's a similar kind of question to what we did before, but before we were looking at the entire circle and we had 2 answers. Now we're doing restricted domain and we only have 1 answer. Now you have to know the restricted domains too. That's going to be something that you're going to end up memorizing. But as you go through it, it'll like become more just something you know. Now these look like really tough, right? Answer in the restricted domain, right? That satisfies the equation. Well, we're going to kind of just work them from the inside out. So sine of pi over 4. Isn't sine of pi over 4 the same thing as sine of 45? And isn't sine of 45 root 2 over 2? So now it's asking me for what angle in the restricted domain, right? Cosine is restricted to first and second quadrant, which here we just wrote it in radians. And again, that should just say less than pi, less than pi. So isn't that just 45? Yeah. But now, since the original problem had radians, I'm going to change my answer to radians, pi over 4. So we're going to answer in radians. Give your answer in radians. This one's interesting because it's sine inverse of sine. You might think, like, don't they cancel each other out? Well, let's see. Pi over 6 is 30, so this is the sine of 30. And the sine of 30 we know is a half. What angle in the restricted domain for sine has a sine of a half? Well, isn't that just 30? And answer in radians, isn't that just pi over 6? So yes, those two just kind of canceled each other out. And if you see that on a future question, you don't even have to go through the work. You could just be like, those things cancel each other out. Next one is, okay, sine inverse of tan of negative pi over 4. So from the inside out, that's the tan of a negative 45, where we might be more comfortable being like, oh yeah, that's the tan of a 315. The tan of a 315 is negative 1. So now I'm saying which angle in the restricted domain for sine has a sine of negative 1, which is negative 90 degrees, aka 270. But we want to answer in radians, so it's going to be negative pi over 2. There's nothing really new here as much as putting together things we already knew, right? Solving these little puzzles. So now it's kind of the same problem, a little bit reversed. Find the exact value in the restricted domain. Okay, fine. And you might notice that these are going to cross each other out, but I'm still going to do the work. The tan inverse of root 3 over 3. What angles in the restricted domain have tans of root 3 over 3 is a 30-degree angle, and what is the tan of 30 is root 3 over 3. So again, yeah, those just kind of cancel each other out. Remember that arctan is the same thing as tan inverse. So the sine of the angle that has the tangent of square root of 3 in the restricted domain. Well, the angle that has a tangent of root 3 is a 60. And the sine of a 60 is root 3 over 2. The angle that has a tan of root 3 in the restricted domain is 60. And the sine of a 60 is root 3 over 2. One more. Okay, fine. The angle that has a cos of root 2 over 2 is a 45 in the restricted domain. That's the easy one. The tan of a 45 is 1. You might feel like you don't have to show any work, but I would at least show that step, right? That just shows me your thinking, and I just think it's a good idea. The last ones are just calculator ones. Arc sine, you literally just type in on your calculator sine inverse of that whole angle. This turns out to be 74 degrees. I don't have these questions on the test because we're not using calculators with sine, cosine, or tangent. So this is kind of redundant here. I can't write 74.13 degrees. Again, I'm just typing on the calculator second cos of that decimal, or second tan, 47.98, 47.98. But, oh, great rating there, yeah. But honestly, you don't have to worry about those because we don't have calculators with sine, cosine, or tangent. We're just kind of showing that the calculator knows these questions and knows the domain restrictions. So there you have it, inverse trig functions.